Hello and welcome to this lesson on multiplying and dividing scientific notation, or numbers in scientific notation. This is our final lesson on scientific notation, so let's get to it. The essential question says, how do I multiply and divide numbers expressed in scientific notation? Did you know that the reason we see a solar eclipse where the moon and the sun appear to be the same size in the sky is because although the sun's diameter is about 400 times bigger than the moon's, the moon happens to be, little coincidence, about 400 times closer to the Earth. So when they line up in the sky, they appear to be about the same size, which is kind of cool. Nice little coincidence of nature. There is no new vocabulary for this lesson, so let's get to it. So in the previous lesson, we were looking at adding and subtracting numbers. And we saw when you were adding and subtracting numbers in scientific notation, you had to have the same power of 10 to add them up. And that power of 10 stayed the same the whole way through the problem. Well, the good news is we don't need that same power of 10. Typically with multiplication, you can multiply any two things. They typically don't have to be alike. In the last lesson, I used the example of fractions. When you're adding fractions, you cannot add 1/4 and 3/7 right now. You would have to make them have the same denominator, rewrite one or both of the fractions before you could add them together. But if you were multiplying, you could. You would just multiply across the top and multiply across the bottom. Well, it's kind of the same thing with scientific notation. When you're adding and subtracting numbers in scientific notation, you need the same power of 10. But when you're multiplying, we can just multiply. And we're going to multiply the parts individually. So I'm going to take my decimal piece and multiply by my other decimal piece. And I'm going to be using my calculator a lot in this lesson because I'm not going to bother doing all this multiplication by hand. So that piece gives us 22.42. Now, we would also multiply our powers of 10 together. And maybe you need to think back a lesson or two, or 3 or 4, to remember how do you multiply two numbers or two powers with the same base? When you multiply powers with the same base, you add their exponents. And I'm pretty sure if I do this 10 to the 4th, ooh, clear there, 10 to the 4th power times by 10 to the 4th power, get out of the exponent, times by 10 to the 9th power, it's probably going to give us, it's giving me an answer in scientific notation, but it is just 10 to the 13th power. Now the last step is checking to make sure our answer is in scientific notation, but it's not. Oops, this piece is too big. We need to rewrite this as 2.242 times by 10 to the something. So my decimal piece got smaller by one place. My exponent gets bigger by one place, giving us 10 to the 14th power. And we're done. So that's multiplication. It's pretty straightforward. It's pretty easy. You just multiply your decimal pieces together. You multiply your powers of 10, adding the exponents, and then make sure your answer is in scientific notation. Here's another example. Now this one we even have one number that's one exponent is positive, one that's negative, and that's fine. I'm going to take my powers of 10 and multiply them together. 2.3 times 1.6 is 3.68. I'm going to multiply my powers of 10 together, adding the exponents. 2 plus a -4 is -2. And I'm checking to make sure my answer is in scientific notation. My decimal piece is good. My power of 10 is good. We're all good. Now, you might be going, or actually, this might have come up a couple lessons ago, but when we were doing those exponent property problems back at the beginning of this unit, we weren't allowed to have negative exponents in our problems. Well, that was true for those problems, but in scientific notation, having a negative exponent is absolutely okay. As long as it's not a fraction or a decimal or else something weird, we're fine. So this problem is good. So here's two for you to try. These are both multiplication, just like the previous two examples. So go ahead and pause the video, try these two on your own right now, and when you're ready to continue, hit play, and we'll go through them together. All right, so if I take and I multiply my decimal pieces together, 6 times by 1.35 gives me 8.1 times by 10 to the power of. When I multiply my powers of 10 together, I am adding the exponents, giving me 10 to the third power, and that was done. There's nothing else to it. These are can be very simple problems. Where the issue comes into play is keeping the addition subtraction rules and the multiplication rules separate in your brain. And the way that that happens best is by practice. Doing more, seeing more, getting familiar with it. That's how you get good. Okay. Multiply. 8.48 times by 3.4 gives me 28.832. Okay, times by 10 to some power. When I multiply my powers together, I'm going to add the exponents, and I get to the 12th power. Oopsie, that is not done. That's not scientific notation. Was the last one scientific notation? Okay, good. I didn't check it, but that answer is not scientific notation. My decimal piece out front is too big. It needs to be a 2.8. So I just need to rewrite this to 0.8832 times by 10 to the smaller by 1, bigger by 1, 13th power. And we're done. So that's how you multiply powers. You multiply the decimals, you multiply the powers, put your answer in scientific notation. Well, what about division? Well, it's pretty much the same thing. We're going to divide the decimals, we're going to divide the powers, and make our answer in scientific notation. So 5.6 divided by 3.3 gives us 1.69 repeated times by, now think back to exponent properties. When we had two powers of 10, or we had two powers of the same base in a fraction like this, what did we do? Well, we either subtracted top minus bottom, 10 to the 4 minus 2, or we did that canceling thing, cancel, 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 cancel. Now, the only difference between that and this is in scientific notation, we always want our power of 10 to be in the numerator. We always want it to be in the top part of the fraction. Okay. So as long as you keep that in mind, we should be good. So here, if I do cancel, 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 I have 2 10s left up top. It is in the numerator. We're good. And we're done. This answer is in scientific notation. My decimal piece is good. My power of 10 is good. The whole thing is good. Letter B. I'm going to divide my decimals. I'm going to divide my powers of 10, subtracting the exponents. We get 8.4 divided by 2.4. That's 3.5. Times by 10 to the, if I do my canceling here, if I cancel 5 here and I cancel 5 here, I'm going to have no more 10s in the bottom, but I'm going to have 7 left up top. And that's where I want them. I want them in the numerator. I want them in the top of the fraction. Looking at this, my answer is in scientific notation. It is, my decimal's good. My power of 10 is good. we're done. All right, letters C and D. I want you to go ahead and pause the video, try these two on your own. When you're ready to continue, hit play, and we will go through it together. All right. So we're going to divide this, we're going to do that, and let's do it. Now these problems were maybe a little bit trickier. Let's see how we did. So 4.73 divided by 8.4. Everybody should have been able to get this part, which is 0.56, and we're going to round there to the hundredths place. All right, so everybody got that part, which eventually we're going to have to change into 5.6 to make it into scientific notation. But for now, here, this. How do we do this? Like, one way to do this is, well, there's two ways I can think of that are both relatively easy. One way is using the subtraction, top minus bottom. 10 to the negative 2 minus 8, top minus bottom, would give us 10 to the negative 10th power. The other way of doing this is you could move this piece up top. He would become a 10 to the negative 8th up top. And then you would combine your exponents together. When you multiply powers together, you add the exponents. So negative 2 plus negative 8 is still a negative 10. Both of those methods work well for us. And then the last thing is just to fix our answer into proper scientific notation. So I'm going to make this a 5.6. My decimal piece got bigger by 1 decimal place, so my exponent gets smaller by 1. And 1 smaller than negative 10 is negative 11. Final answer. So the trickiest part of this problem was the exponent on our power of 10. And if that seemed a little tricky, hopefully you got it now. And actually the same sort of little tricky thing might happen in this next problem. So if you were stuck on this one as well, maybe pause the video again. Now that you've learned what to do, maybe you can try this problem and do it on your own. But we're going to go through it even if you didn't. So I'm going to divide my decimals. I'm going to divide my powers of 10. 4.23 divided by 27.495 is 0.15. I'm going to make it a 4. I'm going to round to this thousandths place. So the 8 makes the 3 round up. Times by 10 to the what power? So I can again do 10 to the top minus bottom. That is 4 minus negative 5, which becomes 10 to the 9th power. 4 minus negative 5 is 9. The other option is you can move to the top and you'd have 10 to the 4th times by 10 to the 5th. And the rule with exponents is when you have two powers being multiplied together, you add the exponents. 4 plus 5 is still 9. So either way gets you the right exponent. You pick the method that works for you. My answer, though, is not scientific notation. So we're going to rewrite 1.54. My decimal piece is going to get bigger by 1 place, smaller by 1 place, gives me an 8. So that's multiplication and division now. So what happens if we have kind of like mixed numbers? Like here, it's just 2.64 times by 10 to the 4th times by 8. Well, there's a couple different ways you could do this. One way is you could imagine this 8 in scientific notation. So then when you'd multiply these things together, you would multiply your decimal piece times by your decimal piece. You'll multiply the power of 10 times by the power of 10. That's the method I kind of prefer. 2.64 times 8 is 21.12. And when you multiply your powers of 10 together, you don't get 0. When you multiply powers, you add the exponents. It stays 10 to the 4th power. And then we change our answer back into scientific notation to 0.112. My decimal piece here is too big. Times by 10 to the something. He's getting smaller by 1. He gets bigger by 1. Makes it a 5th power. And we're done. Letter B, division. You can use the same trick. You can think of this 1.6 as 1.6 times by 10 to the power of 0. And if it helps you think of it, the division as like the fraction like we had been doing, you could then divide this piece, divide that piece, and do the problem. And that's kind of what I do in my head. That's how I visualize and how I do this problem. So then 9.6 divided by 1.6 is 6. 10 to the 7th over 10 to the 0, that's 10 to the top minus bottom is going to be still 10 to the 7th. 7 minus 0 is still 7. My answer is already scientific notation. We're done. So even with mixed numbers, that they're not all scientific notation, all you got to do is just make them scientific notation and then go to town. They're easy. One more for you to try. So here it is, 6.45 times 10 to the 3rd times by 2.8. Go ahead, pause this video, try it on your own. When you're ready to continue, hit play, and we will go through it together. All right, so I would make this a times by 10 to the power of 0. I would multiply my decimal pieces together. I would multiply my powers of 10 together, adding the exponents, which I can do 3 plus 0 in my head is still 3. And 6.45 times by 2.8 I cannot do in my head, so it's 18.06. That number is not scientific notation because my decimal piece is too big, so I make it 1.806 times by 10 to the... He got smaller by 1, he gets bigger by 1, to the 4th power. When I do this on my own, I don't always write this smaller and bigger, but that's what I'm doing in my head. That's how I'm figuring out what to do. This gets smaller by 1, this gets bigger by 1. Look at that. We're on the problem solving already. That's how easy this lesson is. Once you know what to do, they're very quick. There's not much conversion needed. So letter A here says, an Olympic-size swimming pool is in the shape of a rectangle and is about 5 times 10 to the 1st meters long and 2.5 times 10 to the 1st meters wide. Find the approximate area of the water's surface. Answer should be written in scientific notation. Okay, so we're finding the area of a rectangle, which we have the background knowledge to do that. That's just area equals length times width. And I'm going to plug in what they tell me. So they tell me that the pool is 5 times by 10 to the 1st meters long and 2.5 times by 10 to the 1st meters wide. When I multiply, I'm going to do like what I did above. I'm going to multiply my decimal pieces together. I'm going to multiply my powers of 10 together, adding the exponents. And 5 times by 2.5 should be 12.5. My answer is not quite scientific notation because of my decimal piece, so I just got to do a little conversion here. 1.25 times by 10 to the smaller by 1 decimal place, bigger by 1 decimal place, third power. And I should probably put my unit. That is, what was it, meters? Meters squared. So that's the area of the pool. 1.25 times 10 to the third meters squared is the area of the water's surface. Okay, a multiplication. Letter B here says the planet Mercury has an approximate mass of that number. Mars has an approximate mass of that number. How many times bigger is the mass of Mars than the mass of Mercury? Now, I want you to be careful here, because that phrase, how many times bigger, sounds very similar to how much bigger, but it's not. How much bigger would be a subtraction problem. You're looking for a difference. How many times bigger is going to be a division problem. And here's how I can make sense of this. If I'm standing here and I am 6 feet tall, and then there is a little kid, baby person standing here next to me, and they are 2 feet tall. How many times bigger am I than them? Well, I would be 3 times bigger. You would need to stack up 3 of these kids in order to equal, whoa, that person doesn't have a body. You'd need to stack up 3 of these kids in order to equal my height. Okay, I am 3 times bigger. And the way we could do this mathematically, if I take 6 divided by 2, I am 3 times bigger. It is a division problem. How many times bigger is going to be a division problem? Okay? Now, when you're setting up your division, we put the bigger number on the top. So I have to decide, out of these 2 planets, out of Mercury or Mars, which one is the bigger planet? I start by looking at their power of 10, and it's the same. They have the same power of 10. Since they have the same power of 10, I can't use that. Now I'm going to move to the decimal piece. Who has the bigger decimal piece, Mercury or Mars? In this case, it's Mars. So I'm going to put Mars up top. I'm going to put Mercury down below. And I'm going to divide to find out how many times bigger. So let's change color here. So I'm going to divide this. I'm going to divide that. And those circles were both pretty ugly. But let's take our time a little bit better. Divide this and that. There we go. So 6.4 divided by 3.3 is 1.93 repeated. All right. Times by when you multiply or when you divide powers of 10, you do your subtraction or your canceling. Top minus bottom gives us 10 to the power of 0. And it does say our answer should be written, in standard form. So in standard form, actually we're almost there, because if you remember, in standard form, you drop this 10 times by 10 to the power of 0. This just equals 1. So standard form answer is 1.93. So Mars is 1.93, almost 2 times bigger than Mercury. Mars is 1.93 times bigger than Mercury. I try to get everything on one page. I made it too small. There you go. There we go. So Mars is 1.93 times bigger than Mercury. Letter C. I'm going to have you pause the video and do this one on your own. When you're ready to continue, hit play, and we'll go through it together. All right. So it says letter C, the Aztec Stadium in Mexico is a rectangle. It is about this long and about that wide. Find its approximate area. Okay, so length times width again, right? Area equals 1.05 times by 10 to the second power long and 6.8 times by 10 to the first wide. To multiply here, we're going to multiply our decimal pieces together. We're going to multiply our powers of 10 together by adding the exponents. 1.05 times by 6.8 is 7.14. I'm looking. My answer is in scientific notation, so we're done. We just gotta label our answer. It's 7.14 times 10 to the third meters squared. That is the area. Area is in meters squared. My answer is in scientific notation. We're done. Letter D. This is another problem you're going to do. It says here the sun's diameter is about 1.4 times 10 to the 6th kilometers. The moon's diameter is approximately 3.5 times 10 to the 3rd kilometers. How many times greater is the distance of the sun than the diameter of the is the diameter of the sun than the diameter of the moon? Answer should be expressed in standard form. So go ahead and pause the video and do this on your own right now, and when you're ready to continue, hit play. All right, so how many times greater? That is a division problem. And we divide, we're going to put the bigger number on the top, which out of these two numbers, 10 to the 6th power is way bigger than 10 to the 3rd power. The bigger exponent is always the bigger number. So I'm going to put 1.4 times by 10 to the 6th divided by 3.5 times by 10 to the 3rd power. Bigger number on the top. When I divide, I'm going to divide this piece and divide this piece, and then just put my answer in, well, actually in standard form. So 1.4 divided by 3.5 is 0.4. My powers of 10. When you divide powers of 10, you do your canceling, or you do top minus bottom. And if we do top minus bottom, we're going to get 10 to the 3rd power. To make that into standard form, the answer we want this to be 10 to the power of 0. We want no power of 10s left. So to make that happen, my power of 10 is going to get smaller by 3. So my exponent gets bigger by 3. And when we do that, I move my decimal 1, 2, 3 places. 1, 2, 3. We get the number 400. So this is the actual, these are the approximate actual measurements for the sun's diameter and the moon's diameter. And we've just shown that the sun is about 400 times wider, has a diameter 400 times bigger than the moon. It's kind of cool. Letter E is an interesting question. Samantha was calculating the population of the United States. After her calculations, her calculator showed 3.1 EE8. She then calculated the population of the world and got an answer of 7 EE9. Samantha wants to know how many times bigger the population of the world is than the US. Answer should be expressed in standard form. So the reason why this question comes up is there is a standard of mathematics that says students should understand calculator notation for scientific notation. Now, this particular calculator is kind of fancy. Like, if I type in a really big number times by another really big number, and I hit enter, it actually gives me an answer in scientific notation. Here it is. So times by 10 to the 27th power. That's pretty cool. But most calculators don't do that. Here is this calculator. This is a $100 calculator almost. This calculator does not do that. Watch this. 99999999999 times 989898989898. That's kind of what I did in the last one. Enter. See, it says 9.89 E26. It doesn't have times by 10 to the 26th power, although that's what it's trying to show. That's what it's trying to say. So most calculators don't show times by 10. Okay, that's what this is, and this. Some calculators show this as an EE. Some calculators, like this one here, uses just one uppercase E. So it's to make you see that it is scientific notation. Like if we were going to interpret this, this just says 3.1 times by 10 to the 8th power. 7 times by 10 to the 9th power. In fact, on this blue or this silver calculator, right here above the comma, it's in blue. It's kind of hard to see. There's an EE button. Watch this. 3 EE. See, there's two E's here, but only put one on the screen. 9 equals, that's 3 times 10 to the 9th power. Okay, so there's an EE. Sometimes you'll see like 2 E's, sometimes you'll see 1 E. It's a little different from calculator to calculator, which is why I'm kind of bringing this up now, and I'm showing you this other calculator. Ours doesn't have that issue. If I do 3 times 10 to the 9th power, it just does it. It can show that, but most can't. All right, so enough talk about the calculator. Now to actually do the problem. So she was calculating the population, and this was the population of the US. This is the population of the world. And the question is, Samantha wants to know how many times bigger the population of the world is than the US. Okay, so this is that kind of division problem. And then our answer should be in standard form. All right, so I'm going to divide, making sure I put the bigger number on the top. Out of these two, well, the population of the world is bigger than the population of the US. 7 times by 10 to the 9th power over 3.1 times by 10 to the 8th power. And now I'm going to divide my decimals. I'm going to divide my powers. And let's see what we get. 7 divided by 3.1 is 2.25. Let's round that up. 2.26. I'm looking at my calculator. I would make this, the 8 would round the 5 up. Times by, and when I divide my powers of 10, when you divide powers, you either cancel or subtract, and I'm going to get 10 to the top minus bottom is 10 to the 1st power. And, ooh, okay, I need my answer in standard form. I wasn't sure, so I went back and double checked. So if I'm going to write my answer in standard form, I'll do it over here. I'll have more space. I need to write this without a power of 10. I need it to be a times by 10 to the power of 0. So to do that, my exponent piece is going to get smaller by 1. So my decimal piece gets bigger by 1. So 2.6. So the population of the world is 22.6 times bigger than the population of the United States. Okay. Calculator notation. There's an EE button on wherever my fancy calculator is again. Here it is. There's an EE button here. This shows 1 E on the calculator. That's just how some calculators show scientific notation. Last question. The distance from the Earth to the Sun is 9.7 times by 7, or 10 to the 7. Try it again. The distance from Earth to the Sun is 9.7 times by 10 to the 7th power miles. The distance from Earth to the next closest star, which is Alpha Centauri, is this many miles. How many times farther, there's that expression again, how many times farther is the distance to Alpha Centauri than the distance to the Sun? Express your answer in scientific notation. Okay, how many times farther is a division? I think I need another piece of paper because I'm out of space. This question takes up all the paper. So I'm going to divide 2.597 times by 10 to the 13th. I'm just kind of copying the number from here down below. Divide by, it was 9.7 times by 10 to the 7th. I was copying the number from here. So I made sure I put the bigger number on the top. Look at it. The bigger one is on the top. Wait a second. Did I miss an exponent? 13. The 1 didn't follow. There we go. Now the bigger one's on the top. All right, and we divide. So I'm going to divide this. I'm going to divide that. And put our answer in scientific notation. 2.597 divided by 9.7 is 0.268. I'm going to round to that digit. So I rounded to the thousandths place. Times by 10 to the top minus bottom. 10 to the 13 minus 7 is the 6th power. Oh, I forgot to look at my choices to even eliminate choices. Let's see if there's any we can eliminate. If we're trying to express our answer in scientific notation, are any of these not scientific notation to start with? Letter C. That decimal's too big, so it's not letter C. All right, let's see what we got. We got, okay. I need to make this scientific notation. So 2.68 times by 10 to the, well, this piece is going to get bigger by 1 place. My exponent gets smaller by 1 place. So I'm looking for 2.68 times by 10 to the 5th power. And that is letter A. Get out of here. So Alpha Centauri is 2.68 times by 10 to the 5th power times farther than the Sun. Now, in case you are curious what that number actually is like in standard form, that would be 268, 1, 2, 3, 4, 5. I moved the decimal 5 places. 268,000 times farther. Not 268,000 miles, times farther. And the Sun is already 97,000 miles? Yeah. So it's far. It's very, 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 very far to the next planet. Summary. After multiplying, if you get an answer like this, what would you need to do to put your answer into scientific notation? Take a second, pause the video, put down a thought or two, a sentence, and then hit play and we'll go through it together. All right, so what you would need to do is if you get something like this, well, you'd need to make this number the proper decimal, 2.345, or put the decimal in the right place. And when you do that, you need to change the power of 10 as well. If your decimal piece gets smaller by 1 decimal place, your exponent gets bigger by 1 place. It becomes 10 to the 5th power. So now we've learned everything we need to know about scientific notation. We know how to add, subtract, multiply, divide, compare, order, convert, everything. Thank you so much for watching. Until next time, toodles.